Okay, this is the video for 2.2, which is trig functions of non-acute angles. One of the reasons we started using this, we define our trig functions in the coordinate plane, in a circle in standard form in the coordinate plane, or an angle in standard form, was so we could look at non-acute angles. So today we're going to look at a great way to find those angles, or to find those using something called reference angles. Now, this is my favorite way to do all of these trig functions. You have to know how to determine the signs, plus or minus of the trig functions. But other than that, you can use this method here, these reference angles, to find a lot of standard trig values. You may have heard of the unit circle. You may have used the unit circle before. It comes from this. So a lot of, I included in the notes for this section that table of values of our standard angles, the trig function values of our standard angles, 0, 30, 45, 60, 90 degrees. And these are really nice. A lot of angles have these as reference angles. A lot of angles can be written as some combination of these using some identities that we haven't gotten to yet. Okay, so we're looking at an example, and I'll try to walk you through this. So, looking at, I think, what do I have here? 210 degrees. So we're going to look at 210 degrees, and we're going to try to find the cosine of 210 degrees using this thing called a reference angle. And I've got a pretty good idea where that is, since this is 90 degrees, this is 180, this is 270, this is 360, and hopefully you're familiar with that by now. So 270 is too big, 180 is too small. Our 210 has to be in here somewhere, so I'll just draw it someplace. Okay. Now, the reference angle is the angle made between this and the x-axis. It's always between our terminal side here and the x-axis. So there, that makes this little triangle. That is our reference angle right there. So if this was 210, what is this little piece? Well, I take the full length 210, and I subtract off 180, and that gives me this little piece right here. So that's how I find my reference angle. 210 minus 180. Okay. And 210 minus 180 is 30 degrees. That's one of our standard angles. So this big old thing here was 210. Right now it's 210 degrees. This little part here, that's a reference angle of 30 degrees. So what this says, what our rule for this section, like the rule we're going to get out of this, is that the cosine of our angle, 210, is going to be either plus or minus the cosine of our reference angle. It's going to be plus or minus the cosine of 30 degrees. Okay. So, part of this we can answer really easily. Is it positive or negative? Well, over here, over in this quadrant, all of my x's are negative. Right? All the x's are negative in the quadrant 2 and the quadrant 3. Right? And we're in quadrant 3. And since cosine of whatever angle is x over r, well, x is negative over here, right? All these x values are negative. My r values are always positive. So this is a negative divided by a positive So cosine has got to be negative there. So I don't even care about this positive sign. Cosine has to be negative. So I'm going to find the cosine of 30 degrees, but we've got that on our table, right? Cosine starts at 1 and it goes down from there. So this is square root of 3 over 2. Yeah. So my table, yeah, is square root of 3 over 2. Wow, so I know that was a little fast, so let me kind of repeat it there. Cosine of 30 degrees, the reason I care about this table and the reason I've harped on about it for so long is because if I know cosine of 30 degrees, I can very quickly find the cosine of 210 or any other multiple of 30 degrees or anything that has a reference angle of 30 degrees. Like 150 has a reference angle of 30 degrees. 330 has a reference angle. The only thing that's going to change every time is whether or not it's positive or negative. In our case, we found out it was negative because in quadrant 3, my x's are negative. Cosine is determined from x. So it's going to be a negative divided by a positive. Right? Negative, since determined x is negative, divided by this positive, because r is always positive. Negative divided by positive has got to be negative. So that's this section in a nutshell. Finding that reference angle, referring back to that table of values you already know, and then a little bit of work, you have to determine whether the thing is positive or negative. Other than that, this is a super easy section, and I love it. This is how I do all of my trig functions in here. I draw this thing out, I see what its reference angle is, and I know the trig functions of all these standard angles, 30, 45, 60, 90, all that stuff. So that's it for this section. Super easy. I'll give you some problems to practice on. And that's it.